Hello friends, today we are going to discuss next points from the topic number system. In this session we are going to discuss about the binary arithmetics and addition of binary numbers, subtraction of the binary numbers, subtraction using 1's complement and 2's complement method. This point is very simple. Before we discuss about the binary arithmetic, we know that binary number consists of 2 symbols and the base of this binary number is 2, and depending on the position of the binary number the weight will be defined. For example, binary number is represented by 1010.11, that is binary number. Only 0 and 1, these two symbols are used, and depending on the position of the bit the weight is defined. Means, for example, the weight of this 0 is 2 raised to 0, the weight of this will be 2 raised to 1, the weight of this will be 2 raised to 2, the weight of this will be 2 raised to 3. Similarly, after the fraction point the weight of this will be 2 raised to minus 1, this will be 2 raised to minus 2, etc. So the binary numbers are used in computer applications. First we will see what will be the binary arithmetic and how these binary numbers are added and subtraction. So in binary arithmetic we can add or subtract any binary number with the help of different methods. Here we are going to discuss very simple techniques for addition and subtraction of the binary numbers, just like a usual addition and subtraction process of decimal number system. Means in decimal number system 1 plus 1 is equal to 2, 1 plus 3 is equal to 4. Similarly we can add the binary numbers also. So first we will see what are the rules for the binary addition. First rule is 0 plus 0 is equal to 0. There will be no carry. Means 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. But here 1 plus 1 is equal to 1 0, because the symbol 2 is not present in the binary number system. So it is represented by 1 0. So decimal 2 is nothing but binary 1 0. So that is the difference in case of the decimal number system and binary number system. So the next will be 1 plus 1 plus 1. In this case 1 plus 1 we already discussed that 1 0. If we add here again 1, means 1 0 plus 1 is equal to 1 1. So the result will be 1 1, means 1 plus 1 plus 1 is equal to 1 1. So that is rule for binary addition. So remember that in case of the binary number system 1 plus 1 is equal to 1 0, but in case of the decimal number system 1 plus 1 is equal to 2, that is our decimal number. Similarly, in case of the binary number system 1 plus 1 plus 1 is equal to 1 1, but in decimal number system 1 plus 1 plus 1 is equal to 3, that is the decimal equivalent. So these are some binary rules for the addition. Similarly, we are going to discuss the rules for the binary subtraction. So first rule for the binary subtraction, that is 0 minus 0 is equal to 0, 1 minus 0 that is equal to 1, 1 0 minus 1 is equal to 1, because 1 0 is nothing but 2, and that is subtracted, 1 is subtracted from this, that will be the result will be 1. 1 minus 1 is equal to 0. 1 1 minus 1 is equal to 1 0. In subtraction, whenever we come across the step 0 minus 1, what will be the result? In that case we take borrow, means 1 for the upper 0, and then subtract the lower one from 1 0. Means, for example, if we want to subtract 0 minus 1, then how the result will be declared? So remember, in this case 0 minus 1, we have to take here borrow. So take here borrow, that will be the 1, and means result will be 1 0 minus 1, 1 0 minus 1. So result will be 0 minus 1, 1, and that borrow, this indicates that the result will be negative sign. So this is called as a negative result. However, we can also subtract the large binary numbers from smaller binary numbers using two different methods. They are known as subtracting using 1's complement and 2's complement method, because sometimes the large number of bits can confuse the result. For example, 1 1 1 1 1 0 1 0 1 1 1 1 1, we want to subtract this, so it will become some difficult and complicated. So another methods are used for the subtraction of the binary numbers. These are 1's complement and 2's complement method. Now we will discuss in detail what is meant by 1's complement, what is the 2's complement, and how these two methods are used for the subtraction of two binary numbers. So first we will see what is meant by 1's complement number or 1's complement method. 1's complement means replace 1 by 0 and 0 by 1 in binary number, and the result will be known as 1's complement number. Means, for example, 10110, that is one of the binary number. So replace 1 by 0 and 0 by 1, and the result will be 01001. So this number is called as 1's complement of this first number. So 1's complement method is nothing but replacing 0 by 1 and 1 by 0, and the result will be 1's complement. In fact, both the numbers are complement of each other. Means, if we observe the number 110 and 01001, these are complement of each other. So these two are complements. So this is called as 1's complement. 1's complement means replacing 1 by 0 and 0 by 1. Now one more example. 00001001, and the 1's complement number is 110110, means replace this 0 by 1 and 1 by 0. So that is called as 1's complement method. So up to now we discussed that what is meant by 1's complement. 1's complement means exchanging 1 by 0 and 0 by 1, and the result is called as 1's complement. Now we will see what is meant by 2's complement of binary number. Adding 1 in 1's complement is called as 2's complement. Means, first take the 1's complement of the number and then add 1 in that, and the result is known as 2's complement of that binary number. Means, for example, 01001110. So that is suppose one of the number. First take 1's complement of it. What will be the 1's complement? Replace 0 by 1 and 1 by 0. The 1's complement number is 10110001. So that is the 1's complement of the first binary number. So when we add 1 in this 1's complement, then the result will be 2's complement number. So we already discussed that rules for the binary addition. In that case, 1 plus 1 is equal to 10. So 0 will be here and 1 will be carry here. Again 1 plus 1 will be 0 here, 1 will be here. 1 plus 1, and likewise we are going to add the binary numbers. So in case of the 2's complement number, the result will be like this. 2's complement number will be, after adding 1 we will get 10110010, and so this is the 2's complement number of this binary number. Means first take the 1's complement, after that add 1 in that 1's complement, we will get 2's complement number. So adding 1 in 1's complement number is called as 2's complement number. If we again take the 2's complement of this number, so we will get same number. So it is also observed that the 2's complement of 2's complement number is number itself. Means if we take the 2's complement of this number, we will get again the original number. So these are 2's complement of 2's complement number is the same number or number itself. So using this basic, we are going to discuss how the 1's complement and 2's complement numbers are used for the binary subtraction. So 1's complement means replacing 1 by 0 and 0 by 1, and 2's complement means adding 1 in 1's complement. So first we will discuss how to subtract two binary numbers using 1's complement method. So first step, take the 1's complement of subtract. Suppose we want to subtract the two binary numbers. Subtract the two binary numbers 1 0 1 0. So that is your first binary number, and another binary number is suppose 1 1 0 1, that is your another binary number. So this is called as subtract and this is called as minus. So take the 2's complement of this, 1's complement of this number, that is called as a subtract. So I think you are clear that first we have to take the 1's complement of the subtrahend, means number to be subtracted. After that add 1's complement number, means subtrahend to the minus. Means we already take the 1's complement of subtrahend and we have to add this with the minus. Means suppose previous number we discussed that 1 0 1 0, that is your minus binary number, and 1 1 0 1, that is your subtrahend. We want to subtract this. So first take the 1's complement of this, and that 1's complement will be 0 0 1 0. So this will be the 1's complement of this number. Now add this 1's complement with the binary number, first binary number, that is called as a minus. So 1 0 1 0 plus 0 0 1 0. 0 plus 0 will be 0. 1 plus 1 will be 0 and 1 will be carry. Means 1 plus 1 will be 1 0, carry will be here. 0 plus 1 will be 1 and 1 plus 0 will be 1. So result will be 1 1 0 0. Likewise we have to add the 1's complement of the subtrahend with the minus. So next step, if a carry is present, that is called as an end around carry, then add this carry and we will get the final result, and the number is positive. Means for example we will discuss later on, and if end around carry is not generated from the MSB in the step 2, then result is positive. And if end around carry generated from the MSB, the result is positive, and if no carry generated, result will be negative. And this is in the 1's complement form. We will discuss in detail right now what will be the 1's complement and what is the subtrahend. Suppose we are going to discuss one of the number 7. 7 is one of the number, and suppose we want to subtract 3. These two are the decimal numbers. So equivalent of this number is 1 1 1 and equivalent of this number is 0 1 1. So make sure that both the numbers should have equal digit. Means these are the 3 digits, again these are the 3 digits. This is called as a minus subtrahend, and this is called as a minand. So 7 is minand and 3 is subtrahend. Now we have to take the ones complement of this number. So what will be the ones complement of this number? 1 0 0. That is the ones complement number for the 0 1 1. So if we take the ones complement, then add this to the minand, means we have to add this number with the minand 1 1 1, and what will be the result? 0 plus 1 will be 1, 1 plus 0 will be 1, and 1 plus 1 will be 1 0. So end around carry is present here in the MSB. So if we observe that the end around carry is present, the result will be positive, and we have to add this end around carry. So add this end around carry to get the final result. So 0 1 1 plus that end around carry we will get the final result. So 1 plus 1 will be 1 0, 0 will be here, carry will be 1, 1 plus 1 0, and carry will be here, and 0 plus 1 will be 1. So result will be 1 0 0. So 7 minus 3 is equal to 4, and that binary equivalent is 1 0 0. So if the end around carry is present, the result is positive, and we have to add this end around carry to get the final result. Now suppose sometimes means we observe the result largest minus smallest, means 7 minus 3, but in smallest minus largest end around carry is absent, and in that case the result will be negative, and we have to take the ones complement of that number, and we will get the final result, and we have to provide the negative sign for that. Now we will discuss with one of the example. Suppose we are going to subtract largest minus smallest. For example, 7 minus 3. Both are the decimal numbers. The binary equivalent of 7 is 0 1 1. Binary equivalent of 3 is 0 0 1 1. So both are binary numbers, and both have same length. Upper is 4-bit and lower is also 4-bit number, binary equivalent. So first take the ones complement of subtrahend means 3, so that ones complement is nothing but 1 1 0 0. So first we will take the first step, ones complement of that binary number, means subtrahend. After that we have to perform the addition of the ones complement of the subtrahend with the minand, and now 7 is nothing but 1 0 1 1 1, and add this ones complement 1 1 0 0, and the result will be 1 0 0 1 1. Here end around carry is present, and that end around carry indicates that the result will be positive. Means for example, we'll discuss in detail how this will be carried out. So here 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1 0, so 0 will be here and carry will be transferred here, and 1 plus 1 will be 1 0, means 0, and here one end around carry is present, and this end around carry we have to add here, and so 1 added, what will be the result? 1 plus 1 is equal to 1 0, so carry will be added here. 1 plus 1 will be 1 0, so 0 will be here, 1 carry will be added here, so 0 plus 1 is equal to 1, and this 0 will be 0, so result will be 0 1 0 0, so that is equivalent to 4. So we discussed that first we have to take the ones complement of the number to be subtracted, called as a subtrahend, and after that we have to add the first number, means minand, with the ones complement number, and if the end around carry is present, result will be positive, and we have to add this end around carry. Now we add here end around carry. See here, final carry will be generated here, and we added here that one, and the result will be 0 1 0 0. So that will be our final result. So this is the simple method for subtraction of two binary numbers, largest minus smallest, using. Here the carry is not generated, hence the result will be positive and give positive sign, or if sign is absent, the result will be considered as a positive sign. Now we will see what will happen in smallest minus largest, means reverse 3 minus 7 in case of the subtraction. Suppose 3 is one of the number that is called as a minor and subtrahend is called as a 7. So binary equivalent of 3 is 0 0 1 1, binary equivalent of 7 is 0 1 1 1. Now take the ones complement of subtrahend. Subtrahend means this 7, and that is your ones complement. Now perform the addition of ones complement with the minor, means we have to add 3 and this ones complement, means we have to add this 3 and ones complement, and we will get the result 0 0 1 1, that is the 3, and 1 0 0, that is the ones complement of number. So the result will be, what will happen? The result will be given 1 0 1 1. Here end around carry is absent, so result will be negative, and if the end around carry is absent, we have to take again ones complement of this number. And so what will be the ones complement of this? 0 1 0 0 0 1 0 0, and that is your result, and that result is negative, so give negative sign to this. So minus 4 will be the result. Previously there will be the 1 0 0, but that is positive, and here end around carry is present, so result will be negative. So remember first thing that both numbers should have same or equal digit. These are the 4 digit, also these are the 4 digit. If the digits in the subtrahend and minor are different, then we have to add number of zeros to the left side. Means suppose we take the number 1 1 0 1 and the minor we have to subtract, that is suppose 1 0 1. So these are the 4 digits, these are the 3 digits, so we have to add here one more 0 to take it equal digit, otherwise the result will be wrong. So up to now we discussed how to subtract the two binary numbers using ones complement method. Now we will see how to subtract the two numbers using twos complement. This is very similar to the ones complement method. The first step, take the twos complement of the subtrahend. In previous case we take the ones complement of the subtrahend, here we have to take the twos complement of the subtrahend. Here second step, add this twos complement with the minor, and if the end around carry is present, neglect the carry or discard the carry, and if end around carry is absent, then we have to take the twos complement again and give the negative sign. In ones complement method, if the end around carry is absent, we take the ones complement and give negative sign. But here in case of the twos complement method, we have to take the twos complement and give the negative sign. So we will see with one example here. So first we will discuss same example by using twos complement. The result will be same. So 7 minus 3, that is the largest minus smallest. Suppose the binary equivalent of 7 is 0 1 1, binary equivalent of 3 is 0 0 1 1, both are equal length. So take the twos complement of these 3. The twos complement means first take the ones complement and add 1 in that, that will take the twos complement, means ones complement of this 3 is 1 1 0 0, and we suppose add here then 1 0 1 1, that is the what twos complement number. So add this twos complement number with the minor. So 0 1 1, that is the 7, and we add here the twos complement of the subtrahend and the result will be 10100, and here end around carry is present, and that end around carry we have to neglect, and the result will be 0100. So in that case we discard the carry or neglect the carry, and the result will be positive, and that is 0100. So next will be smallest minus largest. In this case we have to subtract 3 minus 7. So same step, take the 2's complement of the number 7, that is your subtract, add this 2's complement with the minus means 3011, and we will get the result like this 1100. Here end around carry is absent, no carry is present here, so therefore result will be negative, and take again 2's complement to get the final result. So 2's complement of this number means we will get this result after the addition 1100. First take the 1's complement 0011 and add 1, we will get 100, and that will be your final result. So these methods are used for the subtraction of two binary numbers using 2's complement method. In the examination there may be the theory question, explain 1's complement or 2's complement method with suitable example, or there may be the example directly, subtract using 2's complement method, subtract using 1's complement method. So you will, the first question may be examination, explain 1's complement method for subtraction of two binary numbers with suitable example. This question will be for 4 marks. Add two binary numbers. There are some examples like just observe the equal number of lengths in the number, and after that we have to convert. Subtract the or explain the 2's complement method for subtraction of two binary numbers with suitable example. This question may be for 4 marks. Or there may be the question using subtract using 1's complement method and subtract using 2's complement. Try to solve these examples, and if any questions you can directly contact. And this is end of the topic number system. So in the next lecture we will start next topic. If any queries you should contact the number 98907455513. Thank you. And this is end of the topic number system from the paper number 2.